Seated on my laptop screen, ready for the Python scene. All those lines of text so clean, let's code and chase that dream. Python world, here we go. Write the script, let it flow.
In this video, we're going to be talking about variable scope in Python. In particular, we're going to be talking about global and local variables when it comes to functions. So what do we mean by scope? Well, scope refers to the region of code where a variable is accessible. So far in the examples we've seen, we know that variables are only accessible after they've been defined by assigning them at least some value. But the rules get a little bit more complicated when we start introducing functions. So understanding this scope helps us avoid naming conflicts, and it also helps us understand where variables are visible and where we can access them in our code. In Python, we typically have to worry about 3 different levels of scope. The first one is built-in scope. At this level, this is where all of Python's built-in functions and objects are accessible, and it covers pretty much everything in Python. By built-in functions and objects, we mean things like the print function, input function, round, power, int, string, float, all of these built-in functions that we've been using. And by built-in scope, we mean that these functions that are built in are accessible almost anywhere in Python, regardless of what module or function you're in. They're always available. The only exception would be if you were to name a local or global variable with the same name that sort of overrides them. The next level is global scope, and this is for any variables that are defined at the top level of a script or module. It also refers to functions defined in a module. And it means that these functions and variables are accessible anywhere in this module after they've been defined. And the only exception would be if they're shadowed or overwritten by a local variable of the same name. And we'll see examples of that later in the video. The last level of scope is local scope. This is for variables defined inside of a function. These variables are only accessible within a function where they are declared. Now for a little bit more terminology before we can move on. And that is the name global variables. So when we refer to something as a global variable, we mean that variable is defined within the global scope. Similarly, when we're talking about local variables, we're talking about a variable that's defined in the local scope. So I know this can be confusing, so let's take a look at an example and break down what the scope of each variable is, as well as where it can be accessed. So first of all, we have built-in scope. This includes things like the print function. We can use the print function wherever we want in Python because it's in the built-in scope. So it covers everywhere. So anywhere in our program, we could use the print function. Now, more interestingly is the variable that we have declared at the top of our program called discount_rate. Because this isn't defined in a function, it is a global variable, and that means it has global scope. This means that this variable is going to be accessible anywhere after it's defined. So we could access this within the calculate price function, and we could also access this outside of that function. For example, if we wanted to also output it at the end of the program. Here you can see that we're calling discount rate to try to figure out what the discount is for whatever this calculation is doing. Next, we have some variables that are local. These are local because they are defined within a function. Discount here is defined within the calculate price function, so that means it can only be accessed in this little box that we have drawn here, which are the lines after it's been defined, but only within the calculate price function. So local variables defined within a function can only be accessed in that function. We couldn't access discount, for example, afterwards, after we've already called the function or something like that. Final price is also local to this function. It can only be accessed in this little rectangle here, where we have already declared it, and it is inside the function. Now, price down here is also technically a global variable because it has global scope, but because it's defined later on in the module, it means it can only be accessed after it's been declared. So we couldn't access this in the calculate price function, but we could access it on any lines in the module that follow. If we had another function definition that came after this, we could access it in that function, but not in the previous one. Only accessible in things that are declared afterwards. Another one here is total. Again, this is in the global scope, and it can only be accessed in lines in this module after it's been declared. Understanding these different scope levels is important because it tells us where we can access these variables. For example, if we know that discount and final price are local variables to the calculate price function, we know that, for example, we couldn't add them to this print line that I've highlighted right now because we can't access those. They're not in the global scope. Whereas discount rate is in the global scope, so if we wanted to add that to this print line, that would be fine. So always while you're programming, have an eye on what scope you're currently working on. Remember, inside of functions is local scope, and you can only access those in a function. Outside is global scope, and you can access those anywhere after they've been declared. Now, we should talk a little bit more about global variables, because this is a common problem area for new programmers. It's important to know when to use global variables and when not to use global variables. So some good uses of global variables are things like constants. These are values that never change. For example, if we're doing some math calculations that needed the value of pi, we might define pi at the top of our program and set it equal to, for example, to 3.14159 or however many digits we wanted. This is a good use because it doesn't matter if our functions are accessing these variables because the value is never going to change. So it's not going to lead to any weird side effects, such as the function returning different values each time we call it, or cause us to be sharing the state of the function in a weird way. Another good use of global variables is for configuration. So maybe at the top of the program, we have a few configuration settings, maybe a certain file it's accessing, or things like that rarely change. And this is another good use because these are effectively constants that functions are going to need to know about to change how they work. We should also be aware of when we should not use global variables. And a big one is modifying the value of a global variable inside a function. This can lead to very hard to understand as well as hard to debug code. It also means our functions could have side effects, meaning running that function could have an impact on the next time the function's run, or an impact of some other part of our code that we didn't foresee. This can happen because if we're setting the value of a global variable or altering it, it could change how the function works each time we run it. This is usually not something we want. We want our functions to be as predictable as possible to the user of those functions. The output should only really change based on the input that we give it as parameters. There are some special use cases, sort of like randint, where we want that to change each time we call it, but generally we want our functions to be as predictable as possible. Another bad use of global variables is to share the state of the program or to give it input. Input to our function should always come through parameters. They should never be set through global variables. That's sort of bypassing the way functions are supposed to work. It leads to a big mess of code that's going to be complicated because there's going to be so many side effects. The state of all these different functions is going to change based on the global variables, rather based on the inputs we're sending to them. It also makes it very hard to test our code. So we can't really use that incremental development approach because there could be other parts of the code that are altering how our functions work. So what are the best practices for global variables? Well, the first one is we should avoid using them as the arguments or parameters to our functions. All values should be passed to functions through parameters that clearly define what the input is for our function. We should never be using global variables to send data into our function unless this is a constant that never changes. Also, when we're defining functions, the value from these functions should be returned using a return statement. We should never be using a global variable to return a value back to our function. While we're talking about best practices, we should also talk about shadowing variable names. So shadowing occurs when a local variable is given the same name as a global variable or some variable in a higher outer scope. This is a problem because it causes the variable in the outer scope to be inaccessible within the current scope. By naming a local variable with the same name as a global variable, we effectively override that name and means that we can only access the local variable because we have no way now of accessing the global variable by that name because we'll always go to the local variable. So the best practice is to avoid shadowing. You should try not to name your local variables with the same name as a global variable. Let's take a look at an example. And here we have a fairly simple program, but there is one little hiccup here. And that is we have two variables with the same name. The variable on the outside, highlighted in red, is the global variable x, and we're setting it to the value of 10. The other x inside the function example is a local variable, also named x, and it is being set equal to 5. The big problem here is to a casual reader of this program, you might think that these are the same variables, and that example is setting the value of the global variable x. But that's not actually what's happening here. X inside the function example is shadowing the global variable x. So within this function now, after we set x equal to 5, we're only accessing this local variable x, and we no longer have any way to access that global variable x. So if we were to run this code, we'd get output that looks like this, where it says inside the function, the value of x is 5, but then when we get outside of example, where we're no longer in that local scope, we get the x that's in the global scope. So we get the output, the outside function is 10. So to summarize, this first line is coming from within the function, and it's accessing the local variable x. Whereas the second line is coming from outside the function after we've already called it, and it is accessing the global variable x. So like I said, best practice is to avoid this to make it very clear to the reader that these are different variables. And it also allows us to still access the global variable x within our function. The last thing we should talk about when we're talking about good and bad practices for function is causing a loop by using recursion. So recursion means calling a function from within the function. And this is a topic that's quite interesting, and you'll get into it more in your later computer science courses, like Computer Science 1027. For this course, we're not going to get too far into recursion, but do note that you can cause some unintended side effects by calling your function from within your own function. So here we have a fairly basic function called bad, and what it does is it inputs numbers from the user and tells them to input a negative number to exit. If we get a negative number, we return. Otherwise, we take the square of the number and we output the square of the number is whatever that value is. But this programmer, instead of using a loop like you should, like a while loop or a for loop, decided to call the function again from inside the function. So you might think that this just makes the function repeat like a loop, and it should be fine. But the problem is this does more than that. It's not causing this function to restart, it's actually calling the bad function again. And that means it's going to create a whole new set of local variables over and over and over again. It's going to start using up the computer's memory by extending the stack further and further down until we eventually hit a recursion limit or we run out of memory. So let's take a look at an example of what this might look like. So let's say we call the bad function, and then we take some input from the user, maybe they input a 10. And then we get an output of 100 for the square, and then we call the bad function again to get input again. But what happens here is num and square aren't reset, or we don't lose them, they're not collected by the garbage collector. They still exist in the computer's memory. When we call the function again, it makes a new variable named num and a new variable named square in a new local scope. And it assigns them a new value, in this case input by the user. Maybe they might input 2, and then square is equal to 4. The problem here is we keep on calling the function and using up more and more memory. The old variables aren't collected by the garbage collector because Python needs to keep track of this path that we're going through calling this function. So when we eventually hit a return, we can return back through all the functions and return a result. This is a problem because it's going to keep using up the computer's memory, and it's also going to keep extending the stack of function calls deeper and deeper and deeper until we eventually run out of depth that we're allowed to use. So for example, we might keep calling this function, keep making new variables. Maybe we have num5, num3, num1, num7, and this is just going to keep going until the user eventually exits. Or what can also happen is we run out of memory, or we run out of depth that we're allowed. So if we were to keep running this over and over again, the user keep inputting valid values and never exiting, eventually what would happen is we would get an error that says maximum recursion depth exceeded, and the program would crash. So we only want to use recursion intentionally. We don't want to use it simply to replace a loop because it will eventually stop working. It's not like a while loop that can just keep running forever and ever. This will eventually crash the program, and it causes all those local variables to be copied over and over again. So don't use recursion to replace a simple loop in your program. Only use recursion with intention, and probably after you've taken 1027 to learn more about how recursion works. So this was a short video. I don't have much more for you. I just wanted to go over some of these good practices with functions, as well as talk about variable scope. If you find this at all confusing, I highly recommend trying it out on PyCharm. Try declaring some global variables, make some functions, declare some local variables in there, and see where you can access the different values. Thank you for watching, and have a great day.